Okay, welcome to chapter 4, lessons 5 and 6. We're going to combine these two lessons. They are comparing properties of functions and constructing functions. Our learning target or objectives for these lessons are comparing properties of functions and determining and interpreting the rate of change and initial value of a function. Okay, there is no vocabulary for either lesson, so we're going to start right with an example of comparing functions. Now, functions can be represented by a table, a graph, an equation, or words. And you can compare two functions represented by different forms. So that's what we're going to try to do today. Okay, our first example, Carlos and Stephanie belong to the Science Museum. Carlos' membership can be represented by the function C equals $9.99, where C represents the cost in dollars. The cost of Stephanie's membership is shown in the table below. Okay, so we have Stephanie's is represented by this one. This is Stephanie's. Okay, this is gonna be Carlos. This is we're gonna fill in Carlos's membership. So we have months for Carlos and cost for Carlos. Okay, Carlos will fill in 1, 2, 3, 4, 5 months. And going back to our problem, cost equals $9.99. So it doesn't matter for how many months. Each month it's going to cost $9.99. $9.99. $9.99. $9.99. $9.99. That's C equals, it doesn't C equal $9.99 times X months, or that's just like when we had examples in chapter 3. We had two different functions like y equaled 2. So no matter what we plugged in for x, y was 2 all the time. Same concept here. Our cost is $9.99 regardless of how many months for Carlos. Okay, so we're going to look at, now we're going to compare, now we have both Carlos and Stephanie's in tables, both functions, we're going to compare them. Okay, our first, describe the rate of change for each function. Okay, rate of change, remember back to chapter 3, is slope or per unit cost. You know, we have slope form to find our slope. Remember in tables, basically they are just helping us with ordered pairs. They put ordered pairs in a little bit more confined area here. So rate of change, we're going to do Stephanie's rate of change first. And remember our rate of change is y2 minus y1 over x2 minus x1. Yes, slope form from chapter 3 is back. So we need to hopefully remember that and what we need to do for rate of change. So Stephanie's rate of change, let's look at the first two pairs. Remember first pair, these are ordered pairs. Remember it was labeled as x1 and y1. Next pair will be x2 and our y2. And then we're just going to plug them into our formula. So we're going to have 10 minus 5, that's our y2 minus y1 over our x2 minus x1. So we find out Stephanie's rate of change is $5 per month. These are the months on the bottom. And we can do the same thing for Carlos, x1, y1, x2, y2. Those are our ordered pairs for Carlos. And we'll plug Carlos into our formula. We've got $9.99 minus $9.99 on top. Our x2 is 2 minus x1, which is 1. $9.99 versus 9 minus $9.99 is 0 over 1. So basically we have no cost change per month for Carlos. Okay, the rate of change, basically Stephanie's or slope rate of change per unit cost, $5 per month for Stephanie's gym membership. Carlos has no cost per month change. So who pays more for a 2-month membership? We just look at the table and tell those Stephanie's 2-month right there. For 2 months she pays $10. Stephanie equals 2 months equals $10. And Carlos, look at Carlos's right there. Carlos equals 2 months equals $9.99. By a penny. Stephanie has to pay more for a 2-month membership. Now, who pays more for a 6-month membership? Okay, what we need to do here, we're just comparing. Okay, so Stephanie equals 6 months. Now we're going to multiply it by the rate of change, which was $5 a month for her. It's going to cost us $30 a month for 6 months. $30 for 6 months. And Carlos, once again, we have 6 months. His rate of change is 0. So he's going to be, once again, he's at $9.99 per month. So this is going to be $9.99 once again. So for 6 months, it doesn't change. It still stays at $9.99 for Carlos. So once Stephanie would pay almost triple of what Carlos is paying for Carlos' gym membership. Okay, moving on. Let's move on to another example for comparing functions in different forms. Okay, we have a certain car has a gas mileage of 22 miles per gallon. The gas mileage of a certain sport utility vehicle is represented by the function compare their gas mileage. So we have a graph and a word function. We're trying to compare the two. Okay, on our graph, okay, we're going to label these here. We can label them on our chart. So this is going to be miles driven. And this is gallons used, our x-axis. Okay, we know our car rate of change is 22 miles per gallon. So now we have to figure out our SUV is what? How many miles per gallon do we get in an SUV? So we have to find our rate of change. Once again, we're going to pick 2 points. We're going to pick our first 2 points we got. Once again, if you look from a line from left to right, the first point you come to, you can always label it as your ones. So you have our x1, y1. Next one is x2 and y2. Once again, we're going to use our slope formula. And we're going to just fill in what we've tagged. Y2 is 38, minus y1 is 19, all over. X2 is 2, minus x1. 38 minus 19 gets us 19, over 1. This is miles. These are gallons. So our SUV is going to be 19 miles per gallon. So you can see if compare the gas mileage for your car or SUV, and that's how we can do it from a word compared to a graph function. Okay, let's move on to our third example. Here we have Lorena's mother needs to rent a truck from 2 different companies. It's shown in the table and graph. Now we're comparing a table and a graph. Which company should she use to rent the truck for miles? Once again, we're going to try to look for a per unit cost and then multiply it by what we need, which we need is 40 miles. So we have Ron's rental, and then our graph, we can tag that as our cross-town movers. That didn't get labeled on sheet. This is cross-town movers. Now we just need to see whose price is cheaper for what we're looking for. Okay, let's look at Ron's rentals first. Okay, we need to know what 40 miles is. That's what the mom's trying to move, 40 miles. We need to find out what our cost is. Once again, let's find our per unit rate of change. So we're going to use our slope formula once again. Once again, these basically just are ordered pairs in a table. So let's make these our x's, x1, y1. Next one will be x2, y2. Have our slope formula once again, y2 minus y1 over x2 minus x1. It's again just rewriting the formula over every time you need it helps you remember it. Doing things over and over again will help you. So let's plug those in. So our y2 is 50 minus 25, our y1 over 20 minus 10. So it gets us 25. This is the cost up on top. That's our dollars. This is our miles. 20 minus 10 is 10 miles. So we can figure out that for every 10 miles, it's going to cost us $25. So our table had 30 miles at $75. So now we added 10 miles here, got us to 40. Now we're going to add our $25. So that would cost us $100 to rent a truck to go 40 miles for Ron's Rentals. Now we're going to check out our graph for crosstown movers. Okay, once again, graph's not filled in completely, but we can still, let's label here though. First we have our cost is our Y, and our miles is our X. And we have 2 points, so that's all we really need to know, so we can find our per rate cost and figure out what 40 miles is going to be. So let's, once again, left to right, our points. The first point on the left gets our 1, so our Y1, X1. Next point is our X2, Y2. Now our slope formula one more time. Now let's fill in what we got. 45 minus 35 over 30 minus 10. That gets us 10 over 20, and that's 1/2 or 0.5. Okay, that is part of our solution, but we still have to find out how many 40 miles what's going to do. Okay, so here on our graph, we have to fill in a few points here. This is 30, 25, 20, 15, 10, 5. Okay, notice on our graph doesn't start down here at the origin at 0. It starts up here at 30. That means we start with an initial cost of $30 with crosstown movers. So before you go anywhere, you're going to have a cost of $30 as a deposit, probably on the vehicle. So we're going to have to write a function for this line. Okay, so we have our Y, which is going to be our total cost. We're going to look for crosstown movers. Okay, this is just like our lesson 4, some lesson 4 problems we've had for chapter 4, writing a function. Okay, so we have a deposit. We're going to call this a deposit of $30. 30 plus then it's going to be 0.5 times so many miles. So it's going to cost us 50 cents, probably 50 cents per mile plus our $30 deposit. So what we have to do is we're going to have to figure out what 40 is. So we're going to plug 40 in for X. So we're going to have 30 plus 0.5 times 40. Our equation, we're going to get 30 plus 0.5 times 40 gets us 20. So in the end, it's going to cost us $50 to go 40 miles for crosstown movers. So crosstown movers would be half as cheap as Ron's Rentals. Okay, we'll work some more with writing functions in this lesson. So if you have any questions on this, please show them down, and we will discuss them tomorrow in class. Okay, we're going to move on though to our next lesson, and our next lesson is, this is constructing functions, so this sort of falls in with place with our last example. Okay, Joan has some photos in her photo album. Each week she has plans to add 12 photos. Joan had 120 photos after 8 weeks. Assume the relationship is linear. Find and interpret the rate of change and initial value. Okay, so it's relationship is linear. That means it's going in a straight line. So that means we're going to use our slope-intercept form here to solve this problem here. Okay. And once again, our rate of change, remember back in chapter 3, rate of change, constant rate of change is our slope. Okay, initial value, that's our startup. That could be a deposit. So that's going to be our y-intercept. y-intercept. So we're going to be looking for y slope-intercept form. That's what we're going to use to try to solve this problem. We're going to fill in with what we got here. First of all, she plans to add 12 photos each week. So the rate of change is given to us. Rate of change is constant, so she can constantly add 12 photos per week. So that right there is going to be our M. Our M is going to be 12. Okay. Now we're trying to find the initial value. Doesn't say anything about what she started with, but it does say what she has after 8 weeks. She has 120 photos. So we're going to make 120 the Y, the total. We're going to make the 8 weeks our X plus our B as our Y-intercept, our initial value. We don't know what that is. So there's our formula for right there. Now let's solve for B. We have 12 times 8, which is 96. We have 120 plus our initial value of B. So now we just have to get B by itself. So we have 96. Any number that does not have a sign in front of it, we consider that positive. Now we have to get 96 moving, so we do the opposite of what we got there. We have plus, so we're going to subtract 96 from both sides of the equal sign. That leaves us 24. Our 96 cancel out. That leaves us just our B. So right there we have our initial startup. So Joan started with 24 pictures originally. Now we can write a function to find out how many photos she has after X amount of weeks. So we do that. We have our Y equals our 12, which is our constant rate of change still, times X amount of weeks, plus our initial startup of 24 photos. So right there, Y equals 12X plus 24. You could find out how many photos Joan had after 52 weeks, after a year. You could double 104 after 2 years. Any number of weeks right there would be able to tell you how many photos Joan has added to her collection. Okay, let's move on to our next example. Here, our next example, the table shows how much money Ava has saved. Assume the relationship between the two quantities is linear. Once again, straight line. We're going to be using y-intercept, slope-intercept form. Find and interpret the rate of change and initial value. Okay, so now they want us to find the rate, the per unit change, and what she started with when she was saving money. Okay, so in this one, we are not given the constant rate of change. We have to find that. Once again, we're in a table. We have our X and Y's. So basically, here's our ordered pairs. So our first step is yes, our slope formula y2 minus y1 over x2 minus x1. We're going to do these first to find our rate of change. So we're going to take our first values are our 1s. That's a y1, x2, and a y2. Okay, now we're going to plug those into our formula. So we have 130 minus 110 over 4 minus 3, which gets us $20 per 1 month. So Ava saves $20 per month. That is our rate of change. So we have our formula, our slope formula we're going to div again. Y equals mx plus b. We're going to fill in our change, which is our m, is 20. Now we're trying to find our initial value. Once again, we don't know what our initial value or our y-intercept is. It's plus b. So now we have to find that. So in order to determine that, we just have to pick an x and a y from our table and plug those into our equation and solve for b. So let's just pick our first ordered pair, which is our 3 months and $110. So our 110 is our y, and then our x value is 3. Okay, once again, there's our formula to solve for our initial value, see how much Ava had originally when she started saving. So let's multiply 20 times 3, which gets us 60. Plus our b equals our 110. Now we can subtract 60 from each side of the equal sign. So 60 minus 110 is 50 equals b. So Her initial startup rate for Ava was she saved $50. She had $50 before she started saving her $20 a month. Once again, we can write our function now to determine how much money Ava has in X amount of weeks. So we have our Y equals, once again, we have our $20 times X amount of weeks plus our initial cost, our startup of $50. So there, that function will let you know how much money Ava has in how many months. In any given months, you can plug in there and then you know exactly how much Ava has in her account. Okay, that does it for our video lesson. Any questions, please bring them to class and we will discuss them at the beginning of class and then work on our activities.